you shouldn't worry about, because it was something that I set up on my end so that anyone can go and use my Chip and Notebooks Live. It doesn't allow, probably will get stuck at the more advanced concepts, because that does need a bit more RAM, and Binder does have a limit on how much RAM it does allow. So yeah, I'm going to be running all of this through Binder and just show you that you should be able to learn the concept without needing to install anything. But later on, of course, get into Docker, because that's a really important concept in software engineering in general. Okay, so let me share my screen. Okay, right, and let's get started. Right, so in terms of all you have to do is go to deepschool.io and press this launch Binder thing, and it'll open up. I believe it's a Google Cloud instance. Right, and once it will take a bit of time, but once it's done, it should open up this hub.mybinder thing. All right, so what I'm going to be going through first, I'll probably go through the sentiment analysis lesson, right? And I'll show you, and I'll go through a second thing if we had given the time on the MNIST dataset. Okay, so what we want to do is, given a sentence, I want to classify whether it is a positive or negative sentiment, all right? So let me just run these things. So Shift-Enter to run. Right, and this will run fast enough. Right, so this is the kind of thing that we have. We have movie reviews, right? So I believe I have 25,000 movie reviews, and so the first one, just to show what it is. So it's a Bromwell High is a cartoon comedy, blah blah blah, and at the end of it, we have a sentiment of 1 or 0. Okay, so 1 is going to be positive. 0 is going to be negative. All right, so this pandas data frame contains all the data that we need. And just to show you that I do in fact have negative reviews, I'm just going to show you the last few, right? So the last one's a sentiment of 0. Okay, so you can see over here towards the end of the movie, I felt it was. So you can start to say that it's starting to be a negative review. Okay, and the shape, just looking at, so we have 25,000 documents, and each of them have a 1 or 0 case. So in this case, we will use some scikit-learn functions. First of all, we'll use this thing called count vectorizer. All right, so what count vectorizer is doing is it's going to be taking every single word and counting how many times that appears in, how many times that particular word appeared in that sentence. Right, so let me just do that. So so now keep in mind, there's going to be a lot of words, right? So for example, you can think that if the word hate appears in that sentence, it's more likely to be a negative review, right? So that's what we're doing. We're counting how many times a particular word appears. We're trying to find out which words are like going to be the key things that make a difference in terms of sentiment, right? So in this case, we have almost 35,000 unique words, right? But if I was to print some of these, the first few things, so over here, what I did was when I did the fit transform, right, to all the reviews, it went and counted every single thing. So let me try and show you some of the sentences, right? So TF, let's try if this will work. Right. Okay. So. So I need to say too dense because it's a sparse matrix, so it doesn't actually give it out. So just yet, okay, I might have killed it just by doing that, which is never a good thing. Yeah, that was a mistake. I should have tried to. Yeah, so kernel died. Okay, let me restart that and just run up to there and not run that thing. So yeah, so the reason that it's a sparse matrix, if you think about it, is so I have 75,000 words, right? So for it to go from a whole bunch of zeros, because remember, every sentence isn't going to have every single word in there. Most of them are going to be 0. It's only a few things that will put the counts against, right? So yeah, but the one thing that I was trying to get at was it has these random things like this. So 0, 0, 0, 0, 0, and a whole bunch of things that probably appeared in one word was noise, maybe problems with how the data was entered, maybe spam as well. So we need to try and get rid of these unnecessary words, right? So how do we do that? So one thing I can tell the algorithm is to say, if the word doesn't appear at least 5 times, don't put it into my data frame, okay? And yeah, so I can't quite remember DF. It doesn't stand for data frame over here. And then this whole concept of stop words. So things like the, I, stuff like that, they don't really change the structure of the sentence, right? So if I have, so if I read, say, so this sentence, unfortunately, this is extremely noisy, as can be seen. Now, if I was to get rid of this is as B, stuff like that, it's still the same sentence, right? You can still understand what I'm trying to tell you, even though I've taken out those joining words. So stop words are things like that, were the most common words that really don't make any difference to the sentence. So I get rid of those things. Yeah, so I do that, make sure everything appears 5 times, so I get rid of things like this. And then once I do this, the number of unique words drop down to, will drop down to 25,000 or 26,000, right? So it'll drop down to this, right? So again, it's a sparse matrix. Don't try to make it too dense in this if you're using the binder, because you don't have that much RAM to play around with. So, and then what I'm going to do is I'm going to split it into a training and test set, okay? And in order to do that, so okay, I don't want you to focus too much on it, but I'll just quickly run through this, because I really want you to focus on the deep learning part, not too much on this stuff, which you will pick up on the way, right? So all I'm really doing is I'm splitting this randomly into a training and a test set. Okay, so I'm not going to spend too much time here. I'm just going to skip this part. And now here we go. So from Keras model part, that's where the deep learning is going to be. And by the way, if you're watching this live, make sure to follow along while we're going. Yeah, so I'm going to import all the essential stuff, right? So sequential is the basic class. So it's a Python class that we're importing to initialize the Keras model. And then we have dense, right? Activation. Now, I'm not, so this is probably a mistake. I probably should have put that over here. Yeah, so what we're going to do is we have these 26,000 inputs, right? And we need to classify that into one thing that will give it a probability of being positive or negative. Okay, so because of that, what we need to tell it is that we're going to connect. Let me try and just show this instead. Okay, so in this case, we're going to have an input of 26,000, right? So in the very first layer, and the very first layer only, you need to say how many inputs are coming. In this case, 26,000. And then that's going to get connected onto 100 hidden units. All right, so it's going to go into the layer above. And we're going to have activation function. And you need to have activation function for any hidden layer, right? And in this case, we're going to have it to be ReLU. I really shouldn't have done it this way. What I really should have done instead, just to keep things cleaner, I suppose, is say activation equals ReLU. And this will work as well. Just send this to keep it a bit cleaner. Not that it's that clean to begin with, but anyway. Now, the last one. So again, I will comment that one out, and this is the activation equals sigmoid, right? So now the last one is a special activation, right? So if you go to deepschool.io, there's a cheat sheet in here. So it tells you for what kind of problem, what kind of activation that you need. So the final activation function is a special thing. So in this case, we have a classification, 2 classes. We have to use sigmoid function. If you use multiple classes, more than 2 classes, we have to use softmax. Okay, and in regression, which I haven't shown so far, you either leave it as a no activation function or linear function. Okay. Anyway, moving on. So I said the activation sigmoid, and then you need to compile this this model. Okay. So the loss, again, that depends on what kind of problem that we're doing. So because we're doing classification class problem, again, the loss function is a binary cross entropy because we're doing 2 classes. It's multiple classes, we have sparse categorical cross entropy. Anyway, so you can look at sheet which kind of loss function that we need. Now, optimizer, I could have left blank because there is a default thing, but I just put allegorith there just to show you that these are the options. And just so that we can read it out, I tend to put this metrics in as well, right? So binary accuracy. Now, the loss function will give you a number that will keep going down when we're training, but metrics is more human readable thing. Again, and you'll see what I mean soon. Okay, so let me run this part. So model.summary. Okay, so the number of parameters. So we have quite a lot of parameters over here. So 2.7 million. Okay, so that's probably a bit too much, but I'm not going to go too much into that this time around. And then what we're going to do is we're going to train our model. Okay, so model.fit always means we're training our model. Okay, so X train, Y train. Epochs is how many times we're going to go through the data, because we're going to have a run through the entire data set at 128 data points at a time, and we're going to run through that twice. Okay. So once we do this, okay, X train is not defined. We didn't run this part over here. That'll take some time. Today will be good. All right, so let me just, oh, looks like the kernel died while we were waiting. So unfortunately, that's one side effect of using free online stuff. So okay, all right. So unfortunately, it seems to be dying. So let me skip to my local version. All right. So I have the installation instructions if you haven't used my DeepSchool website before to do it locally. Right. So let me just show you how it's done on my local machine, because it seems to be dying on Binder. Most likely because it's using too much RAM, especially because there's 2.7 million parameters to play with. Okay. And yeah, so doing this live is always a risk. While we're waiting, let me just check if there are any questions. Okay, no questions. Okay, where were we? Right. Okay. So here we go. So we're training it, and we can see the accuracy is going up, right? So it's at 84% right now, and we start off. Yeah, as soon as we start the second epoch, it jumps to 96% accuracy. But again, keep in mind this is all training loss, right? What we really care about is testing loss. So model.predict. Okay, so predicting on the test set, of course, we don't want to bother with the training set because we just did that anyway. And yeah, now when you do model.predict, it gives you back a probability. It's not going to give you 1 or 0. So if I do that, see over here, it's saying it's 82. Oh, not 82%. 0.08 probability that it's going to be a positive review. So it's a negative review. That's what it's saying. So So what we can do is, if the probability is less than 0.5, it's a negative review. It's greater than 0.5, it's a positive review. Okay, and what I've done over here is look at the accuracy. Okay, so don't worry too much about the NumPy. Just make sure you can understand this line that I've written over here. So 88% of the time, it gets it right. Now, this is the roundabout way of doing it. What I could have done is gone model.predict classes for X test. So now this, yeah, so again, it's reading in batches, right? So that's why it's doing that. So 0 here goes 0, 0, and then 1, 1, so on and so forth. So that's how it does things. Predict classes will give you the actual class label. And let's test some new vectors, right? So, but before you do that, you can't chuck strings into a machine learning algorithm. You need to convert numbers, and TF Vectorizer is what will do it for you, right? So, so TF Vectorizer we defined up here, if you remember, I defined it to be a count vectorizer. So probably a bad name, but yeah, again, it gets rid of stop words. Minimum times it has to appear is 5. So it does the transformation for you, and then once you predict it, I really hated this movie, there's a 38% chance that it's going to be positive, which means that it's more likely a negative thing, right? And if I say I really love this movie, there's 67% chance that it's positive. All right. Okay, so, and last thing that I'm going to go through is how we can improve this model slightly, right? And that's by doing this thing called TF-IDF. So it's similar to count vectorizer, but it does something else that's really smart. So it counts a term frequency, which is the first part. Okay, so the same as counting, and it does this thing called inverse document frequency, where it divides that number by how many times that particular word appeared across all documents, right? So for example, if you had 12,500 documents, the would appear in every single document, right? So it'll divide the by 12,500 in all, pretty much, yeah, in all the documents it'll divide that number. So regardless how many times it appears in a single document, it'll get divided by 12,500. So it really crushes the impact of popular words. So that's what TF-IDF vectorizer does, but you can still say it still needs to appear at least 5 times, and I still don't want to look at the stock words, right? So once we do that, and we do this training, right? So again, like I've specified the model to be exactly the same. The input dimension is still going to be 26,500. And once I do the model fitting, so this might take a bit of time. Yeah, so the accuracy right now is 83%. And yeah, so, and the second epoch, it jumps to 96%. Again, this is just testing. So from memory, the last one, we had 88.2% accuracy. Let me just check that is the case. Yeah, 88.2. And if we, so this is model.evaluate, which will just give you the metrics that you're after, right? So in this case, the loss is unfortunately the first number, which we don't really care about. And the second number is the metrics that you would have specified, right? So once we run that bit, we get 88.6. So it's improved slight improvement, not as big as I hoped it would be, but again, small improvement. Yeah, keep in mind the first number is just a loss, right? So we've done that. And then, yeah, so this is just me manually showing you how to do accuracy, right? So less than 0.5 is 0, greater than 0.5 is 1. And again, if I check, I really hated this movie, the same thing. Now it's giving me an even smaller probability of being positive, 8%, right? So, and I really love this movie. It's 99% accuracy. Yes, and you can do some other cool stuff with Keras, like get the weights and stuff like that. So I just plotted the weights. There was no particular reason why I did that. Model.weights in itself doesn't give you anything back, but yeah, so this is just showing you. So kernel just means weights, and bias is the bias term that you add on, and this for the second layer. Now, doesn't seem to be any questions. Let me just check if there are any. Now, doesn't seem to be any questions. Let me just check if there are any. Now, doesn't seem to be any questions. Let me just. Okay, this stuff repeating. So why the 2.6 million parameters? So that was one of the questions that was asked. So let me just go back to this thing over here. So it shows you where most of the parameters come from, right? So that's where it comes from. And the reason there's that many is because, so keep in mind, my xtrain.shape, there's 26, yeah, so there's 26,967 parameters over there, right? And all those dimensions are going to get connected up onto these 100 things, 100 nodes that's a hidden layer. Okay, the way that I end up with this number is because of this. So I will have 26,967 times 100, but there will also be 100 biased parameters, right? So for each hidden unit, I will add one bias parameter as well. So that's how I end up with this number over here. Now my Google Hangouts isn't working as I hoped it would. So let me just check if there are any other questions. Are there any other questions besides what's going on in here? So if there aren't any other questions, I might finish up. But before I go, one thing that I did want to show you was, so please run through lesson 4, because one thing that I really wanted you to focus on in lesson 4 was the fact that I used pretty much the same structure. So actually, yeah, let me just get rid of that one. So in this example, the model in itself is very much the same, right? So there isn't that much of a difference, except for the fact that I had to use 10 over here. So the task over here is I need to classify it into 10 different labels, 0 to 9, okay? Because these are handwritten digits. In this case, it was a 0. So I need 10 different classes. And the activation, again, if you go to my cheat sheet, because it's a multi-class classification, it's going to be a softmax. And I'm going to be using categorical cross-entropy in this case. Okay, there we go. Yeah, and always use some sort of metric so that you can actually read out what's going on with the training. All right. The main point, looking at the wrong place. The main point that I'm trying to get across is that I use the exact same architecture in both problems, and I still managed to train something that was quite decent. Okay. All right. Let me see if there are. Would naive Bayes result in much lower accuracy than deep learning? Now, naive Bayes. Let me think back to it. It's I'm not entirely sure. So let me go back to the model over here. Okay, so if I remember correctly, and I'm not 100% sure on naive Bayes, I think what you can do is all naive Bayes is it's a 0 hidden layer part. So what you can do is you can say there are no hidden layers, and I'm just going to have the input and the output layer. Okay, so it's just going to be just that. I need to specify the input dimensions, so might as well just run through this. So let me specify that to be the case. If I train that, so it's 87% accuracy, but that's okay. That's training set. Let's look at the test set. So 84% accuracy. What did I have before? I had 88%, I think. Yeah, I had 88%. Yeah, so it does. So the accuracy does go down a bit, as you would expect, right? Because there's no hidden layer, so the complexity of this model is lower. So the or rather, I should say the flexibility is lower. But saying that, the number of parameters also died down significantly. Any other questions? Right. Okay. So I think I might leave it there. So if you do have any questions or comments, feel free to ask, and I'll answer them on the comment section at some other later point. I might conduct more of these Google Hangout sessions once I figure out how YouTube streaming works a bit better. But yeah, so that's all for now. Now, if you're and one last comment with lesson 4 part 2, I have used this whole train with generator. I think fit generator somewhere in here. That's it. Yeah, so here fit generator. Don't worry too much about that. So all it is just it's reading from the hard disk rather than from memory. So that's one way of, if you're dealing with big data, that's one way of dealing with it. And when you're just using a laptop, for example, right, rather than have everything in RAM. But otherwise, lesson 4 part 2 and lesson 5 should be very much the same concepts that are covered. Okay, so thank you. And so with that, I think I'm going to hang up. So thanks for watching, and I'll catch you guys later.